A development team implemented a PreToolUse hook for Claude Code meant to restrict file modifications within the infra/prod directory. The script successfully identifies the restricted path, outputs edit blocked protected production path to stdout, and terminates with an exit status of 0. However, during validation, the agent proceeds with the file edits without acknowledging any restriction. Why is the block failing to trigger? Option A: hooks are incapable of restricting tool usage. Option B: the hook is required to provide the rejection reason via the hook-specific output/additional context object. Option C: the hook must terminate with a non-zero exit status and send error details to stder. Option D: the hook executes too early to inspect file paths. Okay, let's break down the question. We are dealing with a PreToolUse hook, which should be used to restrict file modifications within a specific directory. The script is working correctly because it can show the blocking text, and it terminates with an exit status of 0. This scenario explores the life cycle of agentic tool hooks. We are looking at how an automated system interacts with custom validation scripts. The question asks us to identify the specific failure mechanism that allows an agent to bypass a supposed restriction. It centers on understanding how the communication between the external script, the orchestrator, and the model must be structured to ensure that a block signal is correctly interpreted and honored by the agent.
In my view, the correct answer is option C. For a PreToolUse hook to effectively block an operation, it is not enough to simply print a message to standard output and exit cleanly with a 0 status. The hook must trigger a failure signal to the orchestrator by exiting with a non-zero status, typically a 2. Furthermore, the error message itself must be directed to standard error, or stder. This is crucial because the system captures stder content and feeds it back to the model as feedback context.
As for the other options, option A is incorrect because hooks are indeed designed to perform exactly this type of validation. Option B references an incorrect API pattern that does not exist in this context. Finally, option D is wrong because PreToolUse is the correct lifecycle point for interception. Using a post-tool-use hook would be far too late, as the file modification would have already occurred. Remember that providing clear feedback to the model via stder is key to preventing unwanted tool usage.